So to find the velocity for the pendulum, it's a little more complicated than for a ball falling because the pendulum moves in both the x direction and the y direction. So the velocity starts off at 0, so I'm just going to put 0 in this first cell, but now I need to write a formula here. During the time that passed from 0 to 0.03 seconds, the ball went from this position, the x and y position, to a new x and y position. It moved in both directions. So to find the velocity, we're going to find the distance it moved and divide that by the time. So we're going to start with an equals. To find the distance, we have to use the distance formula. So it's SQRT, open parentheses. And now we got to take the distance it moved in the y direction. So that's going to be a new set of parentheses, and then d9 minus d8. That's how far it moved in the y direction squared, plus how far it moved in the x direction, which is going to be C9 minus C8, and it's that quantity squared. So that's the distance formula, and I have to take the end of the square root. So the square root of the distance it moves in the x plus the distance it moves in the y, both of those squared, tell us how far it moves. And now I have to divide that by the time, which is B9 minus B8 tells us how much time has elapsed. So when I put that big old formula in there, it calculates the velocity. And once I've written the formula, of course, I can drag it down, all the way down, and it'll find the velocity, which I need for the kinetic energy. Okay, so I'll click back on it. Here's the formula that you are looking at. It's a big old long one.